Number 1. Your test scores in one class are 78 and 86. What are possible scores you can earn on your next test to have a test average between 82 and 88 inclusive? Now, inclusive means that 82 and 88 could be possible test scores. It means it includes them. Notice inclusive sounds like include. Now, to find the average of something, you add up the numbers that are there, and then you divide by the number of numbers there are. So to find the average of our test, we're going to have 1, 2, and then our next test, which is 3 tests. So we add up the scores of those 3 tests, and then divide that number by 3 to find the average of them. So we don't know what our third test is, but we know that test plus the other 2 divided by 3 would have to give us our average. Now, we know that has to be between 82 and 88. And we said inclusive, so it will be less than and equal to, and less than and equal to. Always make them less than. So our average has to be between 82 and 88, but could also include the numbers 82 and 88. So let's go ahead and solve that. It is called a compound inequality because there is more than one inequality involved with it. This is a conjunction, meaning our solutions is a range of numbers between 2 endpoints. So now to solve it, we start by crossing out the 3 to get rid of the fraction and multiplying both sides by 3. 82 times 3 is 246. 88 times 3 is 264. Now we add up 78 and 86, and we get 164. Now we subtract 164 on both sides, and we get 82 is less than or equal to x, which is less than or equal to 100. So that means my test average will have to be between 82 and 100, but it can also include those numbers because that's what inclusive means. So that's the answer. So we're going to type in for our answer 82 and 100. And it says use ascending order, meaning go from smallest to largest. Start with the 82 and then type 100. And then that's number 1. Number 2, it says write a compound inequality that represents the following phrase and then graph them. It says all real numbers that are between -6 and 3 inclusive. Inclusive meaning that it includes -6 and 3. Now, the inequality to represent inclusive means equal to for the inequality. So when we have a less than or equal to, that would mean the inclusive, that line under it. The only one with both of these having lines under it would be -6 is less than or equal to n is less than or equal to 3, which is b. That's the answer for number 2. Graphing it means when it's inclusive, it means closed circles. So the only one of these but 2 closed circles is C. So the graph for 2 is going to be C. Before, it says to solve the compound inequality and graph the solutions. Now, compound inequality is when there are 2 inequalities together, either as an AND statement, meaning it's an interval that's conjoined, or it would be an OR statement, meaning it's a disjunction with graphs going in separate directions. So this one's going to be a conjunction. It's going to be an interval. So what we do, if you're not sure where to start, is cover up the left side and think of what you would do if we had just this. What we would do is add 6 to both sides. So that's what we're going to do. Add 6 to both sides. 9 plus 6 is 15, 5p, and 24 and 6 is 30. So we have 15 is less than 5p is less than or equal to 30. Now we divide everything by 5 to get this p by itself. So we get 3 is less than p is less than or equal to 6. Okay, now we're going to go ahead and graph that. So we have 3 is less than p is less than or equal to 6. So we type that in first, the whole inequality. Now our graph, when it's a conjunction like this, it'll be a conjoined interval for our graph. Notice there's a open circle on the first one, there's no line under it, will be a closed circle for the second because there is one. So the only one that could be is D. Open circle on the left, closed on the right. So that's the answer for number 4. Number 5, it says solve the inequality and graph the solutions. Now this one is an OR statement, so that means we're simply going to solve each inequality separately and then graph them separately but on the same graph. So starting by solving the first one on the left, we add 5 to both sides, which gives us 5t is less than negative 25. Divide both sides by 5, and we'll get t is less than negative 5. Now that's our first answer. Now, the second inequality, we start by subtracting 3 on both sides. We'll get 3t is greater than 6. Divide both sides by 3, and we get t is greater than 2. So the final answer will be t is less than negative 5, or t is greater than 2. So now let's graph that. So the choice for t is less than negative 5 or t is greater than 2 will be C. So choose that first. Now to graph it, when it's an OR statement, it's going to be going our solutions can either be on one side or the other side. So they're going two separate directions. It's a disjunction, plus they're not connected. Now they're both non-equal to inequalities, so that means open circles. So that tells me it has to be A or G. Now we have at negative 5 and positive 2. So that means G. A is on negative 2 and positive 4. So it has to be G. And that's the answer for number 5. Number 6, write the interval as an inequality, then graph the solutions. Okay, so remember that parentheses are when there is no equal to in the inequality, brackets are when there is. So our endpoints are negative 1 and 3. For our inequality, since these are both parentheses, it would be both less thans without the equal to. So less than x is less than. So negative 1 is less than x is less than 3. So now let's graph that. So typing in negative 1 is less than x is less than 3. And now for the graph, it's going to be between 1 and 3, but both open circles because there's no lines under either of the inequalities. So that means it has to be B. And that's number 6. For 8, it says write the inequality in interval notation and then graph the interval. So since we have two inequalities, we're going to have two sets of interval notations. So starting with the first one on the left, remember, parenthesis is when there's no line under it, bracket is when there is. There is a line under it here, but for the first endpoint on the left, it's going to the negative direction forever. So we have first an OR statement, then negative infinity, because it's going to be a negative infinity going to the left forever. And we know there's always a parenthesis when there's an infinity. Now we have that negative 6, which we established there's a line under it, so there has to be a bracket on the negative 6. On the other side, we are starting at 2 and going to the right forever. It says it's greater than 2, so we start at 2. Since there's no line under it, it'll be a parenthesis. And then we're going to the right forever, so it'll be a positive infinity. And there's always a parenthesis on the infinity. So then this will be my interval. So let's go back and graph it. So a little trick for this one. Since this is multiple choice, and this is OR, it means it automatically has to be the one with the OR. So it automatically would have to be B. So that's just a little trick. Graphing it is two separate inequalities going in opposite directions. It will be a closed circle on the left and open on the right. So that has to be B. That's the answer for number 8. Solve the inequality and then write it in interval notation. So we first start by subtracting 4 by everything. So we have 2 is less than x is less than or equal to 8. So now we got to write this in interval notation. So our endpoints are 2 and 8. Remember, less than without the equal to, without a line under it, means parentheses. With a line under it means a bracket. So for the 2, there's no line under it, so there's a parenthesis. There is a line under it with the 8, so we have a bracket. So then that's this inequality in interval notation. And that's the answer for number 9. Number 10. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. The lengths of the two sides of a triangle are 19 feet and 35 feet, and find the possible lengths of the third side. Now this one is actually easy. Add the two numbers up and subtract the two numbers. So adding 19 and 35 gives me 54. Subtracting the two numbers, we'll have 16. And that's it. So always put the smaller number where it says it's going to be greater than that number, and it's going to be less than the larger number. So put the smaller number and then the larger number. And then that's all you do for number 10. 12. It says solve the following compound inequality and graph it. So you have 3x is greater than or equal to negative 12, and 5x is less than or equal to 10. Now we have n, so that means it's a conjunction. So let's solve the first one on the left first. Divide both sides by 3, you get x is greater than or equal to negative 4. Then we divide both sides by 5 for the second one, and we get x is less than or equal to 2. So the answer would be x is greater than or equal to negative 4, and x is less than or equal to 2. Writing it as a conjunction, you would have negative 4 is less than or equal to x, which is less than or equal to 2. That's because x is greater than negative 4 or greater than or equal to negative 4, and x is less than or equal to 2. So now let's graph it. So we know it has to be b, so then type in negative 4 and 2. Graphing it, it will be a conjunction, so we know it can't be A, definitely not D. Between B and C, or E, will be our interval. Now we know it has to be both with lines under it, so it's both filled in, so it has to be either B or E. This is negative 4 and 2, this is negative 2 and 4. Our answer is negative 4 and 2, so it has to be B. And that's the answer for number 12.